What's up, you guys?
Hey.
So, for our ISS experiment, we did spider silk. And basically the plan of our experiment is that we're going to send one small hobo spider and one small silverfish in a type 2 FME, which is one clamp, up into space. And then what we're going to do, so I'm just going to read sort of the procedure now with it. So what we're going to do is this. Once it's up on the ISS, you're going to unclamp that first clamp, alright? Which is the only clamp. And so the two silverfish and spider meet. And then you're going to wait until the spider eventually gets pretty hungry and then eats the silverfish. But when it starts to go for the silverfish, if it catches it, it's going to wrap in silk. And that's the point of the experiment. You're going to want to take that silk with tweezers, get it out of the test tube, and put it under a microscope and compare it with normal Earth silk produced by spiders that have lived on Earth and from the space silk. Then, you collect the silk, put it under a microscope, but don't kill the spider. Leave the silverfish in there so the spider does have something to eat. Then, once back on Earth, dissect the spider with dissecting tools like little knives, tweezers, stuff like that. Anyway, dissect it, and then compare the normal anatomy of a spider with the microgravity influence anatomy of the hobo spider that was in the space. Okay, so compare normal anatomy and microgravity influence anatomy, and compare to regular spider web, and then send us the results. Okay.
Analysis. So, when the experiment is completed, you'll be looking for a couple things. Any changes in the behavior of the spider, any changes in the anatomy of the spider once you dissect it, and any change in the web of the spider under a microscope to compare with the normal web. Here's an anatomy of a spider.
Okay, pretty complicated.
Very. Let's talk about the facts. The scientific name is
Eratogena argestis.
Vanzan. The range is the species is native to Europe, but was brought over to North America by shipping boats. Prey, small bugs, other spiders. Predators, robins, other birds, lizards, house/wolf spiders. Dimensions, about the width of a penny, and identification. They have two fangs that are quite long and are not hard to miss. They also have a V shape on their abdomen, pointing towards the head, cephalothorax.
Okay, why should you choose our experiment? Spider silk, many people think is the strongest in the world, but it's actually not. It's the strongest organic material, meaning that it's not man-made. So, it's 5 times stronger than steel and 3 times stronger than Kevlar, but this only applies when the spider silk has been woven together into a thicker strand.
I think that's it.
Not yet. So, okay. Police and military use Kevlar for making vests and bulletproof defense, I guess. But spider silk, if you would end up using a vest made out of spider silk, it will be much lighter and durable. So it'll be lighter, durable, you can move much faster. Okay. If you had a pencil-thick strand of spider silks, but if you wove a lot together, it could stop a Boeing 747 in mid-flight. That's crazy. But spider silk does not directly absorb, so it wouldn't just slam into it and stop. It slams into it just like a fly, and it stretches a long way, and then it just springs back. What? Okay. You should not just choose our experiment because it's benefit humanity and everything. You should also choose it because it's not that hard to conduct, and most likely spiders are very adaptable animals, and they can live in very small crafts for their entire lives. So, I think that's all.
Okay. Yeah. Thank you.
Oh, so now I'm going to show you guys the pictures. So,
Prey.
That's the prey, the silverfish. And this is in Madagascar, there's really big spiders, and they make super big webs. And the people there made a robe out of spider silk, which is an example here. This is a picture of a hobo spider. That's an anatomy, like we showed you before. And here's the materials. You need a small hobo spider, small silverfish, a microscope, type 2 FME, and tweezers. And silkworms. Here's the life cycle. So obviously, as you know, takes quite a while from the egg stage to get all the way there. And when spiders make eggs, they do an egg sac, so tons of little eggs. And then here's the male and the female spiders compared to each other. So female is bigger, much bigger. Thank you for listening.
Bye.
And have a great day.